Hi everyone, in this video we are going to discuss about how to find the parametric form of the equation of tangent at a given point on a circle. Let's suppose we have a circle like this whose equation has been given as x squared plus y squared plus 2gx plus 2fy plus c equals 0. So obviously the center will be at point negative g comma negative f according to the equation. And let's suppose we have a point P on the circle like this, and this point is located in such a way that the radius through this point makes an angle of theta degree or theta radian with the horizontal. So if we suppose that CA is a horizontal line, which is the horizontal radius here, and CP is the radius through the point P, and if the angle PCA is equal to theta degree or theta radian, then what would be the coordinates of this point P? Well, the coordinates will be like this. It will be negative g plus r times cosine of theta, and y coordinate would be negative f plus r times sine of theta. Negative g is the x coordinate of the center and negative f is the y coordinate of the center, and in that case the coordinates of the point P would be like this, and CP will be equal to CA, and each of them will be equal to the radius of this circle. And from the given equation, what would be the radius? We know radius is equal to square root of g squared plus f squared minus c. And what would be the slope of CP? Well, obviously that will be tangent of theta. So I have noted it here. Slope of CP is equal to tangent of theta. Next, I am going to draw the tangent through the point P. Let's suppose the blue line is the tangent line through the point P on the circle. And now CP will be perpendicular to the tangent line. We have already seen that in a theorem of circle that the radius is always perpendicular to the tangent line. So CP will be perpendicular to the tangent line. And in that case, we can say that the product of the slopes of the tangent line and the slope of CP will be equal to negative 1, because we know that the product of the slopes of two mutually perpendicular lines is equal to negative 1. So here I have noted that slope of tangent multiplied by slope of CP, that will be equal to negative 1. I have already created a separate video on this topic. I have shared the link in the description. Feel free to watch that video. So in this case, what would be the slope of the tangent line? Well, it will be negative 1 over slope of CP, and we already know that the slope of CP is tangent of theta, and theta is a given angle. In the question, theta will be provided, theta will be given. So theta is known, that means tangent of theta is a known value. So we already know the slope of CP. Then we can easily calculate the slope of the tangent line. That will be negative 1 over tangent of theta, and that can be written as negative cotangent of theta. So now we can see that we know the slope of a line, which is the tangent line. We know its slope, which is negative cotangent of theta. And also we know the coordinates of a point on that line, and that point is nothing but the point P, whose coordinates again are known, meaning negative g plus r times cosine of theta. That will be a known quantity because we have been provided with the value of g, and we could calculate the value of r, and theta has been provided. So negative g plus r times cosine of theta, that will be a known quantity. Negative f plus r times sine of theta, that will also be a known quantity because the equation of the circle has already been provided, and the theta angle will be provided also. So those are all known quantities. That means we know the coordinates of a point on this line, and we know the slope of this line. So using the point slope form of equation of straight line, we can easily derive the equation of this tangent line. So what will be the equation then? Well, the equation is going to look like this. It will be y minus y sub 1 is equal to slope times x minus x sub 1. Now what is y sub 1? Well, y sub 1 can be assumed to be the y coordinate of the point P. So let me make a quick note here that if this is our y sub 1 right here, the y coordinate of the point P, and this is our x sub 1, which is the x coordinate of point P, then the equation of the tangent line will be y minus y sub 1 is equal to slope of that line times x minus x sub 1. That is the point slope form of the equation of a straight line, and that's exactly what I have done here. I have written here y minus the y coordinate of the point P is equal to the slope of the tangent line, which is negative cotangent of theta, times x minus the x coordinate of the point P. And next we just need to simplify this a little bit. If we remove the inner parenthesis, the equation going to look like this, and that is the equation of the tangent line. Whichever form is easier to remember for you, feel free to remember it that way, but that will be the equation of the tangent line for a circle whose equation is x squared plus y squared plus 2gx plus 2fy plus c equals 0, and the slope of CP is equal to tangent of theta. Next, we are going to take a special case where the center of the circle is located at the origin. And in that case, we are going to see how this equation going to look like. When the center is at the origin, we can say then negative g will be equal to 0 and negative f will be equal to 0, because that will be the coordinates of the center at the origin. That's the coordinates of the origin. And from here we can say then g will be equal to 0 and f will be equal to 0. Now I'm going to plug in 0 for g and 0 for f in our equation here. Our equation is going to look like this: y plus 0 minus r times sine of theta. So in place of f I have used 0 is equal to negative cotangent of theta times x plus 0 minus r times cosine of theta. In place of g also I am using 0. And if we simplify it, the equation going to look like this. In place of cotangent of theta, I have written cosine of theta over sine of theta. And if we cross multiply, the equation going to look like this. And then if we remove the parenthesis, the equation is going to look like this. And then if we bring the x and y terms to the left hand side and bring everything else to the right hand side, the equation is going to look like this. And the right hand side can be written like this. Also, you know the Pythagorean identity of trigonometry that says sine squared theta plus cosine squared theta is equal to 1. So in place of sine squared theta plus cosine squared theta, I am going to use 1. So essentially the right hand side is going to be r times 1, that can be written as just r. So ultimately our equation is going to look like this, and that will be the equation of the tangent line when the center of the circle is located at the origin. Next, we are going to take an example. Let's suppose we have an example like this. For the circle x squared plus y squared minus 6x minus 8y minus 11 equals 0, find the equation of the tangent at point P such that CP makes 60-degree angle with the positive x-axis. So here the point P is located in such a way that the radius drawn through that point would make a 60-degree angle with the positive side of the x-axis. And of course C is the center of the circle. So let's get started with the solution. If we compare the given equation of the circle with the general form of the equation, then we can say that 2gx is equivalent to negative 6x, and from here we can say g is equal to negative 3, and similarly we can say 2fy is equivalent to negative 8y, and from here we can say f is equal to negative 4. And the constant term c is equal to negative 11, that's provided in the given equation of the circle. And then we should be able to calculate the value of r. We know r is equal to square root of g squared plus f squared minus c. Let's plug in the values of g, f and c. Then we can write it as square root of negative 3 squared plus negative 4 squared minus negative 11, and that turns out to be square root of 9 plus 16 plus 11, and that will be equal to square root of 36, which is equal to just 6 unit. I have noted 6 unit because it's the radius of the circle, and here we are taking the positive value because we are talking about the radius of a circle. We should not take a negative value for the radius. Radius should always be taken as a positive value. So square root of 36 has been written as positive 6 unit. That's the radius of the circle. Also theta has been given as 60 degree. So I have noted it here. Next, let's try to find out the equation of the tangent at point P. I'm going to use the original form here. Y plus f minus r times sine of theta is equal to negative cotangent theta times x plus g minus r times cosine of theta. Next, we are going to plug in the values of f, r, theta and g. So our equation is going to look like this: y plus negative 4, because the value of f is negative 4, minus r is actually 6. So 6 times sine of 60 degree, theta is 60 degree, is equal to negative cotangent of 60 degree times x plus negative 3, because the value of g is negative 3, then minus 6 times, because r is equal to 6, so 6 times cosine of 60 degree. And if we simplify a little bit, our equation going to look like this. And next, if we bring all the terms to the left hand side, our equation will look like this. And in the next step, I am going to multiply both sides of this equation by a square root of 3. So all the terms will be multiplied by square root of 3 on the left hand side, of course, and on the right hand side 0 times square root of 3 will be 0. So our equation will look like this. It will be square root of 3 times y minus 4 times square root of 3 minus 3 times square root of 3 times square root of 3, that would be 9. So that's negative 9 there, and then plus it would be x and minus 6. All of that will be equal to 0. And also, if we keep the x and y terms on the left hand side and bring the constant terms to the right hand side, then the equation could look like this. And that is the equation of the tangent line. In fact, you can use the previous form also, the form in the previous step where all the terms are on the left hand side and the right hand side is 0. You can use that also as the equation of the tangent line, or you can use this form also as the equation of the tangent line. I hope everything made sense. Thank you for watching. See you in the next video.